In 11-4, Geometry in 3 Dimensions, we are going to look at simple closed surfaces and polyhedra, how to draw three-dimensional shapes, why there are only 5 regular polyhedra, and we'll discuss simple closed surfaces that are not polyhedra. A simple closed surface has exactly one interior, no holes, and is hollow. Looking at the first example, this is called a triangular prism. The base consists of a triangle, and the top also consists of a triangle. And we're connecting those triangles with segments that are perpendicular to the base. This is known as a triangular prism. The second figure has a base that's a rectangle or a square, and the sides are triangles. This is known as a pyramid. The third figure is just a sphere. It is a ball-shaped figure. And the fourth figure is a cylinder, but it's a special type of cylinder since the segment is not perpendicular to the base and the surface. This is known as a oblique cylinder because it has an angle. It is not perpendicular to the surface. Let's look at figures that are not simple closed surfaces. If you look at the first figure, this is not a simple closed surface because there's a hole in it. So this cannot be a simple closed surface. The second example, there is no holes, but we have more than one interior. We need one interior to be a simple closed surface. This one has 2 interiors. So it cannot be a simple closed surface. Let's draw ourselves a sphere. And remember, the sphere consists of a point and all of the points that have a given distance from that point. Let's call that the radius. And we're going to form our sphere. But remember, a sphere is not a two-dimensional object, so we have to rotate it in all directions, and you will realize that we get a figure that kind of looks like a ball. If I rotate it in all directions with the radius of r, I will get a figure that is a ball-shaped object. A solid is the set of all points on a simple closed surface together with all of the interior points. So basically, it's a simple closed surface, but we include all of the points on the interior of that surface. A polyhedron is a simple closed surface made up of polygonal regions or faces. The vertices of the polygonal regions are the vertices of the polyhedron. The sides of the polygonal regions are called the edges of the polyhedron. To simplify the definition, a polyhedron is essentially a figure that consists of faces that are polygons. So the face of the polyhedron consists of multiple polygons connected together, such as triangles, squares, pentagons, hexagons, and so on. So a polyhedra again consists of polygon faces. So we have a triangle for the top, a triangle for the base, and the sides are rectangles. For this pyramid, the faces are triangles and the base is a rectangle. Let's look at some things that are not polyhedra. A sphere is not a polyhedra because the surface does not consist of polygons. An oblique cylinder is not a polyhedra. The top and the bottom do not consist of polygons. A circle is not a polygon. And the third figure is not a polyhedra because it is not a simple closed surface, and it consists of circles, and circles are not polygons. The last one consists of faces that are rectangles, triangles. However, it is not a simple closed surface, so therefore it cannot be a polyhedra. A prism is a polyhedron in which two congruent faces, the bases, lie in parallel planes, and the other faces, lateral faces, are bounded by parallelograms. You can see in this figure we have a triangular prism. The bases, the triangle on the top and the triangle on the bottom, are parallel with each other, and they're connected by parallelograms. The parallelogram, or the segments DA, FC, and EB are parallel with one another. As we saw before, this is a triangular prism. It is a right triangular prism because the bases are perpendicular to the sides of the parallelograms. This is a quadrilateral right prism because we have 4 sides for these polygons for the bases, and they're connected by parallel lines. Now, this is also called a rectangular right prism because these are essentially rectangles since they have 4 sides. A hexagonal right prism consists of 2 bases that are hexagons, and again they are perpendicular with the sides, and the hexagons are parallel with one another. The hexagonal prism here is oblique because although the bases are parallel with another, the base does not meet the sides at a right angle. It's an oblique angle. A pyramid is a polyhedron determined by a polygon and a point not in the plane of the polygon. The faces of the pyramid meet at a point called the apex. The faces of the pyramid are known as lateral faces, and the base in this case is a triangular base, but we could have different types of bases. There's different types of pyramids. The right pyramid is where the lateral faces are congruent isosceles triangles. Remember, isosceles triangles have 2 sides that are congruent. 2 sides that are congruent. So in the first figure we have a triangular pyramid because the base is a triangle, but the lateral faces consist of isosceles triangles. These 2 are the same distance or length. The second figure is a square pyramid. We have a base that is a square, which means all of the sides have the same length, and we have angles that are 90 degrees. The third figure is a pentagonal pyramid. Remember, pentagon is a figure with 5 sides, or a polygon with 5 sides. So pyramids are classified by their base. We could have hexagonal pyramids, a base with 6 sides, octagonal pyramids, a base with 8 sides, and so on. If one or more corners of a polyhedron is removed by an intersecting plane or planes, the polyhedron is called a truncated polyhedron. In the first figure, we have a truncated square pyramid with parallel bases. We essentially took a pyramid and cut the surface off for the apex, and we have a truncated polyhedron. This is a cube that we slice the corner off of it, and it becomes a truncated cube. This was a truncated 1, 2, 3, 4, 5, 6, so it's a hexagon. And we slice the top off of it at a straight plane. So this is a truncated prism, a truncated hexagonal prism. A convex polyhedron is a polyhedron in which a face segment connecting any 2 points in the interior of the polyhedron is in the interior of the polyhedron. This simply means we have no indentations. So let's look at a simple polyhedron. I will draw myself a cube. And according to the definition, if I pick any 2 points on the interior of the polyhedron, that entire segment will be inside the figure. So any 2 points, I will have it being inside the figure. No part of it will be outside the figure. There are no indentations. Regular polyhedrons are convex polyhedrons whose faces are congruent, regular polygonal regions, such that the number of edges that meet at each vertex is the same for all the vertices of the polyhedron, which essentially means we have a polyhedron that consists of the same type of polygons. So we have a cube, which is a regular polyhedra. All of the faces consist of squares. A tetrahedron is a pyramid in which all of the faces consist of congruent triangles. We have an octahedron here, where all of the faces consist of triangles that are congruent. And if you count the faces, there are 8 faces. Hence the prefix octa. Let's look at more regular polyhedra. These are a little bit complicated. The first one is the dodecahedron. It consists of 10 faces, and each of these faces are pentagons. All of the faces consist of congruent pentagons. The icosahedron consists of a figure with 20 faces, and each of the faces are actually triangles, congruent triangles. So let's summarize some of the polyhedrons that are formed. The first one consists of a tetrahedron. A tetrahedron consists of 3 faces. We have 3 faces here, and each of the face is a triangle. At each point, the vertices, there are 3 polygons that intersect at that point. At every point, there are 3 polygons that intersect. For the octahedron, we have 8 faces, and the octahedron consists of triangles, again, congruent triangles. Each of the interior angles of the triangles are also 60 degrees, and each of the points has 4 faces that intersect that point. For the icosahedron, we have a figure with 20 faces, and each of these faces are again triangles with interior angles of 60 degrees, but it takes this time 5 triangles at each intersection point. So there will be 5 polygons that intersect at a point for each of these vertices. A cube consists of squares. All of the segments are congruent, and the face is congruent with the base at a 90-degree angle. The dodecagon is a polyhedron with faces that are pentagons, so with 5 sides, and the interior angle of each pentagon is 108 degrees, and the dodecagon has 10 faces while the cube has 6. Here is some patterns that you could use to construct regular polyhedra. The first one, you would need to have 6 squares connected together in this pattern, and at each of these dashed lines you would make a fold and you can form your cube. For the tetrahedron, you would have a figure like this with a triangle, and inside the triangle we have another triangle, a smaller one, and at these dashed lines we can fold those edges up to make a tetrahedron. And these are really fun little projects, especially during a pandemic. You can have so much fun making these regular polyhedra. A cylinder is a simple closed surface that is not a polyhedron, formed as a segment AB parallel to a given line that traces a planar curve other than a polygon. A cone is the union of line segments connecting a point P with each point of a simple closed curve. The simple closed curve and the interior of the curve. In the first figure, we have a right circular cone. The base is a perfect circle, and we're connecting all of the edges of that circle to a point P known as the vertex. And this forms a right circular cone. For the second figure, we have a simple closed curve for the base, but this curve is actually concave. There is an indentation, and we connect it to a point P, and this connection point is not perpendicular to any of these lines that connect from the edge of that figure to that point. So this is an oblique cone.